Right, so we're now moving on to our final video of the year. This is it. We're finished. After this, school is pretty much done. All right. Even though this isn't going to be on your report card, it's very important that you do take this seriously, because next year and the years after, you will be learning this in more detail. And I'm a true believer that the first time you learn something, it can be very difficult. The second time, the third time, and so on that you see it, this becomes easier and easier. So this is meant to help you for next year, so that when you see this for next year, it's not the first time. You've at least experienced it, even if it's just for a small percentage of time. You did experience it before, you have heard someone talk about it, and you've practiced it before. So this is going to help you for the years to come. So please take this seriously, even though this isn't going to be on your report card. All right, but what we're going to learn today is graphing on a coordinate plane. We have already learned what a coordinate plane, and we've already learned what a coordinate plane is. We've already learned how to plot points on a coordinate plane. Now we're going to graph lines. So what our learning objective for today will be that students will know how to graph an equation on a coordinate plane. All right, let's go ahead and talk about this a little bit more before we get into any kind of problems. Well, what is a coordinate plane? Well, a coordinate plane is a two-dimensional plane that is created from the intersection of two axes that we have. That's our y-axis and our x-axis. All right, we have learned this before. Our x-axis is the horizontal, or y is the vertical. What we learned before is that this will break it up into four separate quadrants. We learned that this is quadrant 1, that this is quadrant 2, that this is quadrant 3, and that this is quadrant 4. We also learned how to reflect points. We learned how to graph and plot coordinate planes or ordered pairs. So this here, if we label this point A, if I ask you what point A is, well, our x value, because along our x-axis we're moving 3, so our x value is 3, and our y value is 2, so it would be the point 3, 2. If I ask you what this point is here for B, well, along our x we also moved 3, so that will be 3, but now along our y we moved 1, 2, 3, 4, 5 in the negative direction, so that would be -5, and so on. We can go ahead and plot and figure out what all these different points are as a coordinate or as an ordered pair, because remember, we learned that we first write our x value and then we write our y value. But now what we're going to learn is not only just plotting these points, but then drawing a line between them to go ahead and graph our equations. All right, let's go ahead and move into this and talk about it a little bit more before doing any examples. All right, so now what we're going to do is we're going to discuss equations that have two variables. All of our equations we've been doing before have one variable. 3x is equal to 18, or x minus 15 is equal to 32. We've only done one variable equations. Now we're going to focus where there's two. The way that they're going to appear is y is equal to 5x minus 1, something like this, where we have two variables. We have our x variable and we have our y variable. We're going to talk about how we can name them very shortly. All right, so now, an equation with two variables represents two quantities that change in relationship to one another. So as we change our x, if I substitute in 1 for x here, well, my y in that case will be 4. When I substitute in 2, my y is going to change, because now it's no longer 1 times 5, but it will be 2 times 5. All right, so they change in relationship to one another. They're not just randomly changing. They're changing the same pattern every single time. And then a solution of the equation in two variables is an ordered pair that makes the equation true. So as long as if we plug in our x and our y value into our equation for our x and our y, and it holds true, that means it is a solution. All right, and we'll talk about how that appears on our graph momentarily. But first, let's go ahead and practice determining if ordered pairs are solutions or not. All right, so for A, tell whether the ordered pair is a solution of the equation. So remember, our ordered pairs are written x comma y. So that means for this 3, that is substituted in for x. And this 6 can be substituted in for y, because I know that 3 represents my x based on where it's written in my ordered pair, and 6 represents my y. So my equation is y is equal to 2 times x. Well, in order for me to see, is this a solution, I will substitute 6. And I'm asking, does this equal? Does this actually equal? So I'm asking, I'm not saying 100% beforehand. I'm trying to figure out, does it work? So now 6, does this equal to? Well, 2 times 3 does equal 6. So do they equal? 6 does equal 6? Yes. So that means that this is a solution. right? Because it satisfies the equation. The next one, y is equal to 4x minus 3. Well, x is going to be a 4 and y is going to be 12 because we know it's an ordered pair of x, y. So I'm plugging it in. 12. Does this equal to 4 times 4 minus 3? I'm asking, does it equal? And let's figure it out. Well, does 12 equal to 4 times 4 is 16? So 16 minus 3 is 13. Well, does 12 equal 13? No, we know it doesn't. So no, this is not a solution. Right? This is the very foundation of what you need to know when you guys are going ahead and doing this later on, as to when you guys learn the graph, when you learn this in more in depth. You guys need to understand that these ordered pairs, when it's a solution to our equation, we can go ahead and substitute it in, and it gives us a true statement as 6 is equal to 6. All right? If it gives us a false statement, it means it is not a solution. And we'll talk about how that appears in our graph momentarily. All right, now when we graph, when we have this y is equal to x plus 3, right? Just like in science where we have independent and dependent variables, we have those in mathematics as well. All right, so the variable representing the quantity that can change freely is our independent variable. And you're going to learn that our x, let me change this, our x is our independent variable. All right, our x is our variable that we can change depending on how we want. The dependent variable is the value that depends on the independent variable. So as we change our x, our y is going to change with it. So our y is referred to as our dependent variable. All right, our x is going to be our independent and our y is going to be our dependent. Our independent variable, we can change freely like we want to, and our dependent variable depends on how we change that x value, right? So whenever you see y and x together, our x is represented for our independent variable, our y is represented as our dependent variable, but it doesn't have to always be x and y, all right? It can be, I'm filling up a pool, so I'm going to say P is equal to our pool water height. And I can say T is going to represent time. And I can say that our pool is filling up with 3 liters per minute. So our equation would be 3 is equal to PT. In this example, our independent variable will be our time, right? Because we can say, well, how long is it going to be, or how much water will be filled in after 30 minutes, after 10 minutes, after 20 minutes? Our time is always going to be our independent variable because that is changing freely. Nothing is going to say restricting our time from changing or not. So our time is always going to be our independent variable. And our pool's water depth in this case would be our dependent variable. Right? So it doesn't always have to be x and y. This is how we will see them the majority of the time. Just know that our independent is one that can change freely, and our dependent is the one that depends on the other variable. All right, so for this question, just real quick, we'll go through it. It says the equation y is equal to 64 minus 8x represents the amount y in fluid ounces of chemical remaining in a flask after you pour out x cups. Identify the dependent and independent variable. Well, right away we know our dependent variable is always going to be equal to our y variable, which in this case is our chemical remaining in our flask. All right, our independent variable is always going to be our x variable. And this, in this case, our x is saying how much cups we pour out. So cups poured out. All right, so now we can identify our dependent and independent variables and how much of the chemical remains after we pour out 5 cups. Well, when we're pouring out cups, does this represent our x or our y? This represents our x. So when we have the equation y is equal to 64 minus 8x, I know if I want to solve how much is left over after I pour out 5 cups, that means x is equal to 5. So I need to substitute 5 in for my x. So y is equal to 64 minus 8 times 5. Y is equal to 64 minus 40. So in this case, I'm going to write it over here. Y is then equal to 24 ounces. So that means that's how much we would have left. All right, since we're pouring out however much we want to out of this flask, that's why that is our independent variable. Our dependent variable, how much is left, is depending on how much we're going to pour out. All right, so you can always think about, well, which one is going to affect the other? When we're pouring something out, that's going to affect what's left in our flask. In order for us to change our flask, we have to either pour out or pour in. So it's not going to be, that is not going to be the independent variable. Well, magically, our flask is just going to change its height without pouring something in or out. All right, there's one other question we're going to go through, which is going to be finally graphing an equation, and then that'll be it for this video. All right, so now we're getting into graphing an equation in two variables. We're going to keep this very, very simple. All you're going to do is create a table. You will create an x and a y. Which one are our independent variables? Well, our independent variables are our x. So that means I'm going to choose numbers I'm going to substitute in for x. I'm going to just, for now, only choose 0, 1, 2, and 3. All right, I'm just going to choose those 4. We're not going to choose any negative numbers yet because we haven't learned how to multiply a positive and negative. So we're just going to keep them 0 to positive numbers. Right now, if I said x is equal to 0, what do you think we can do to solve for y? We've already done this. If I know what x is, I just substitute it in for y. So that means y is equal to 2 times 0 plus 1. Well, 2 times 0 is 0. So now I have y is equal to 0 plus 1, or y is equal to 1. So that means when x is 0, y is 1. So this now gives me an ordered pair of 0, 1. So I can plot this. My x value is 0, so that means I'm here along my origin. My y goes up 1, that means I'm here. All right, so now the next one, let's go ahead and plug in y is equal to 2 times 1 plus 1. Well, I know 2 times 1 is 2, so 2 plus 1 is going to give me 3. So y is then equal to 3. So this gives me the ordered pair of 1, 3. So I can plot the point along 1. Here's my 1 for x. I go up 1, 2, 3, and there is my point. To find out for the next one, same thing. I'm going to plug it in. I'm going to go ahead and do it over here. Y is equal to 2 times 2 plus 1. So y is equal to 4 plus 1, or y is equal to 5. So that will then give me the ordered pair of 2, 5. So I'll plug this in. 1, 2, 1, 2, 3, 4, 5. And the last one we can go ahead, I'll do over here as well. Y is equal to 2 times 3 plus 1. Well, y is equal to 6 plus 1. Y is equal to 7. And that gives me the ordered pair of 3, 7. So I will go ahead and plot these points at 3 and at 7. All right, now, when we're graphing these solutions, we can plot these points. In order for us to finish this graph, right, to show all of our solutions, what we do is we actually draw a line going through them. All right, we would take a ruler out and we would go ahead and draw this line. Let me just go ahead and draw this a little bit better. It's hard for me to use a ruler when I am drawing on this tablet, so I need to go ahead and just use this line. I'm just trying to make it as best as I can. So here is our line going through. All right, now, what this means is any point, this isn't really going through it straight. Let me just fix this. All right, any point that falls on this line is a solution. So any point that I pick on this line, whether if it's here, whether if it's here, here, any point that falls on this line will satisfy this equation. This line represents all of our solutions. All right, just like when we learned when we were graphing our inequalities, when we were graphing x is less than 3, well, here is our x is less than 3. We know that this line represents all of our solutions. Any point that falls on that line would be a solution. That happens here as well. All right, for now, if you just know how to plot a graph, you'll learn about it next year and the years after in more detail. But for right now, you just need to be able to plot this. And the way that you plot it is you pick the points, 0 through 3, 0 through 2. You pick at least 3 points, and then you plug them into the equation. And you figure out, well, if x is 0, what does y equal? If x is 1, what does y equal? Once you get those points, you get an ordered pair. We plot them on our graph, and we draw a line through it. It's really not that difficult. I realized we just went through a lot of this in a small, short of time. I would have probably broke this out into multiple videos, but it's just meant to give you an introduction. All right, so that is it for this video.